Okay, in this podcast we're going to take a look at how to make solutions, and I have the caveat here that we want to do this for quantitative analysis. So whenever you're asked often on AP exams what is the preferred glassware to use, or what's the preferred cleaning method or lab technique, and whenever you're doing that you should assume that you're doing quantitative analysis. So let's take a look at what that means. So quantitative analysis means you're trying to determine some quantity, usually the mass of a substance, the concentration, moles, and usually interested in a reactant or a product in a reaction. So the kinds of experiments you do where quantitative analysis is necessary include gravimetric analysis. Gravimetric analysis is just a fancy word for massing. So if you're doing something, for instance, where you have a reaction and you're isolating a precipitate, that would be gravimetric analysis. Or if you're taking a hydrate and trying to find its formula and you're driving off the water and measuring the dry hydrate, that would be gravimetric analysis. A titration is a form of quantitative analysis. And spectrophotometry, where we're using absorbance of colored substances to determine the concentration, also involves quantitative analysis. And the key thing when we're doing quantitative analysis is that accuracy is really critical. So you have to make the right choice about the glassware to use. You have to make sure that your glassware is clean so you don't have any contamination. And you have to make sure that your substances are well mixed. So we have lots of options in the lab for what kind of glassware to use. Generally, when we're measuring something out in the lab and we're trying to find the volume of a liquid, for most things we can just use a graduated cylinder to measure that volume. But if we're making a solution that requires that's being used for a quantitative analysis lab, then we want to make that solution in a volumetric flask. Okay, and there's different size flasks and they all have a line. There's only one line on it, so if this is a 100 milliliter volumetric flask, and that line is the line that tells me I have 100.00 milliliters, and that's the precision that you get. Okay, so the best glassware to make a solution in is a volumetric flask because it's much more precise than a graduated cylinder would be. And if we are dispensing something for making a solution or doing a titration, we want to use a burette, which we will use during the titration, or a dispensing pipette, which is the kind that has the bulb on the top. Okay, so let's take a look at what we would actually do in making a solution. So let's say we want to prepare 250 milliliters of a 0.125 molar calcium chloride. The first thing you have to do is figure out which calcium chloride you're using, because in the stock room you'll find both anhydrous, which means without water, and you'd find the dihydrate. So let's assume that we're going to be using the dihydrate. So then you need to figure out how many moles of calcium chloride you're going to need. And because molarity is moles of solute over liters of solution, then moles is simply molarity times liters. So I take my molarity, which is 0.125 moles per liter, times 0.25 liters, and I come out with 0.03125 moles. And I keep the extra sig figs here. Then I want to determine, okay, so how much of the calcium chloride dihydrate do I want to mass out for this? So I take the number of moles, and I multiply it times the molar mass, and making sure I include the water in there. And I get 4.594 grams of calcium chloride. So I'm going to try to get as close as I can to that. And our balances will take you three decimal places. So we might not be exactly there, but that's what we're going to try. Okay, so here's what you do. You gather all your materials, and one of the things I suggest is you get a beaker with water, distilled water, and you put it at your bench. That's going to be a lot easier for you to work with than taking this volumetric flask and taking it over to the big jug of water and trying to fill it up. You need a lot of water. So get water, you need a funnel, you need a nice full wash bottle. So the first thing you're going to do is weigh out your solid, the one that you calculated. You're going to put some water in the flask, in the volumetric flask, before you actually add your solid, because you don't want that solid sticking to the bottom and not getting mixed. So maybe you fill it a third or half of the way with the water. And then you're going to add the solid. Now sometimes you can just fold your weighing boat and tip it in. Sometimes you need to use a funnel to get that to go in. I've added a picture of the wash bottle here because what you want to do is use that wash bottle to wash that solid, any residue from that solid, into the flask. And if you're using a funnel, you're probably going to need to use that water to get the solid to go down. You need some of it dissolving. But make sure you get all of the mass off of this weighing dish or weighing paper, because you don't want to make sure you leave any solid behind that's going to affect your results. Once you've done that, you can put it on a magnetic stirrer so that it's stirring. You may need to add a little bit more water to get this to really dissolve. And so you would just take the beaker and pour it. And once it all appears to be dissolved, you're going to take your wash bottle again, and you're going to fill it up to the line. And remember, you're going to report this to 2 decimal places. So if it's a 10 milliliter volumetric flask, you're reporting this as 10.00. The other thing you should always do when you've made a solution is you should label it. So you should label it as, let's say you're making 0.125 molar. This is calcium chloride, dihydrate. And then you put your initials. Sometimes you put your bench number or your period number. Okay, and that's going to do it.